Hello. In this video, we'll be looking at a display and the files and file structure on that display. So in general, while some of our displays differ in the files and file structure, specifically there's some difference between like an XM display and an ARM-based display, so an x86-based display and ARM-based display. We've attempted to keep the files and file structure very similar between the two, so most of it should be the same, although there may be some slight differences. So I may end up making a video with those differences on an x86 based display, discussing specifically the differences. In this training, we'll be using a VA display, so an ARM-based display. So keep that in mind. If you're using an XM, some things might be different. Okay, so this video assumes that you can connect to the display already, that you know how to connect. If not, please go watch those videos. Right now we're using PuTTY to connect to a VA display, so my IP address is 192.168.0.2. So I'm going to log in as root and SUSE root. Okay, so the first thing I get to here is just the hashtag tells me that we're in the display, and we can move to the root directory of the display. In this video assumes that you know how to get around the display with Linux commands. If you don't know that yet, then please go watch the basic Linux command tutorial video. So I won't be going over moving around the display much here. Okay, so we're in the root directory, and we can see a lot of the folders within the root directory. So we're going to focus primarily on the user folder in this video, the opt folder. Most of these folders here, besides this opt folder, are specific to the Linux operating system. And we're not going to go too much into where certain things are within the Linux OS, simply because for the most part you shouldn't need to know them. There may be a few things that come up depending on the complexity of your application, where you might need to interface with the Linux OS and some drivers or base files, but that's probably not the norm. So we're just going to go over what's in the user folder. So this opt directory here is where all of the user-specific files are stored. So as you create Qt applications and code assist applications, these will be put in the user file. We also store our Maximatech or CrossControl specific libraries in this folder, and images and things like that. So we're going to move into this folder. And you'll notice I have some folders that you won't have, just because I've created some applications with Qt that are stored on the display. So like Diag GUI, Hydraulics International, Persistent Variables Demo. These are all Qt applications I've stored. Okay, so let's first move into the etc folder. So we can type that and take a look here. So there's two folders I'll come into here that are pretty important. So let's first move into this init.d folder. And if we look here, these are all executable script files. And in the init.d folder, these are scripts that are called during the startup of the display. So with this folder, you can essentially tell the display what you want to be turned on or turned off as it's starting. And you can also modify these scripts to do some things that you want. So, for instance, if this startup GUI here starts by default the Qt4 settings application that comes up on the display as a default when you first get it, if you haven't modified it at all. So we could, for instance, turn that off by making that file not executable in this folder. So you'll see now it's this white color, it's not executable. And if I were to restart the display, now when the display tries to execute this file, it won't execute, and the default startup GUI application will never start. In this case, I don't really want to do that, but just as an example. We can also, modify what is actually started, which we've covered in a different video. So I won't go too much into that, but we can, take a look at what's in that file with nano, also covered in a different video, but we see the application that's starting up, and it's this startup launcher GUI. So we could change that within this file if we wanted to. We could also add new scripts in this init.d folder, and I'll show you where they're linked. So, so the init.d folder contains the script files that are starting applications as the display starts. So really they're cross-control specific applications in this file. For the base Linux applications, those are handled in the Linux OS. Okay, so let's move back one file structure and now take a look at this rc3.d folder here. And in this folder, we'll see some other important files. So we'll see ones that sort of match the files that we found in the init.d folder. But you'll notice these are blue and have this S number trailing the name. So if we look at, as we've covered in a different video, blue files indicate a symbolic link. So if we look at what these symbolic links are actually pointing to, we'll expand my window a bit so they all appear on one line. There we go. Okay. So we can see here the S04 points now to the script file in init.d. So all of these files are symbolic links pointing to the script or executable files in init.d. These S numbers before the file name indicate the startup priority of this script. So this S04 will start first. It is #1 priority. So as the display starts to boot up and it handles or goes into this RC3 folder, it's going to say, okay, what has the lowest S number here? And that will be executed first. So it's going to execute this and then come to S15 and S17. So we can change the startup priority of files in here. As a note, if you do change the startup priority, sometimes that causes problems in, sometimes if you try to start, for instance, like your application before the CAN bus is started, and in your application you're initializing the CAN bus, it could potentially cause an error because your application will say, okay, initialize the CAN bus, and it tries to initialize it, but it hasn't been started in the Linux system yet. So you have to be a little careful when changing these startup priorities. If you have something working, you can mess around with it, but if all of a sudden it doesn't work, this is a good place to look that, maybe you've changed the startup priority. There's other ways that you can mitigate, that sort of thing in your actual application by, try catches and trying to determine if something started before you've initialized it. But that's sort of outside the scope of this. But for instance, if I wanted to change, the field bus success startup time, I could move S27 to, for instance, S99. So anytime you give an S number after S90, it is a late startup, or the display will start it much later than anything else. So if you're having trouble with, like I said, like you're trying to initialize something or getting an error with initialization, a good thing to try is to move it to be started later, or after S90. So we can just, for instance, move S99, we'll just call it the same thing, field bus success. Okay, so now essentially I've moved the field bus success module, or this script, to be executed last, or a late priority. So if I were to restart the display now, the field bus success module would start later. Yeah, so this is where you would want to go to change the priority of the applications that are starting on the display. I'm gonna go ahead and move that back though. You can also, for instance, create new symbolic links here. So if I wanted to create a new link, I could do that in this folder. So for instance, the splash screen is a good example. There's a knowledge base article on how to create a splash screen, but essentially in that article we go over how to create a new symbolic link in this folder, and it's ln-s for symbolic, and then the file you want to point to. So in this case it could be in the etc folder structure, and all of the files we're already using, so I won't go ahead and do this, but yeah, check out the knowledge base article for examples on how to create the splash screen. But you could create other scripts that you wanted to be executed on startup of the display. If you wanted to configure something else within Linux or within your own applications, the init.d folder contains the scripts, and the rc3.d folder tells their startup priority. Okay, let's go back to the opt folder now and look in the lib directory. So cd lib. Here we see all of the shared objects, or shared libraries that we've installed on the display, mostly for Qt here. So, if you ever, for instance, in your virtual machine, have removed the libraries located there, they are all copied here, and the ones on your display in the opt-lib folder, the shared libraries, should match the libraries located on your virtual machine for the ARM-based displays. Okay. Next, let's look at the CrossControl folder. So CrossControl here is actually just a symbolic link to mtcc, so we can move to either one. Okay, so in this folder, one of the important things you'll probably, as you start to modify like gauge images and things like that, there's an images folder here where, oops, where we keep all of the images that are used for Qt widgets. So you'll notice like CC round gauge here. So if we look in here, we have our background and things like that. So again, these match what's installed on the virtual machine. But if you modify a gauge or modify any of our widgets on the virtual machine to make them look different, and you were to build your application for the display, unless you need to essentially copy those images over to the display. And this is the folder it's looking at. So if you create like a custom gauge, and we'll just call this CC round gauge custom, for instance, and you've created that on the virtual machine, you'll need to copy it over to the display, and you'll copy it over to this folder here. So this is the opt CrossControl or MTCC images folder is where you'll copy it. So the images folder contains all of the images to support our widgets within Qt. Okay, back to opt. Bin contains the executables for the data engine server and field bus access. So these are the binary files for those two components. Those are pointed to by the scripts within the init.d folder, so really you shouldn't have to mess around with those too much. Qt5 contains a lot of the libraries and things to support Qt5 on the display. Again, you shouldn't need to do anything with that. Gone over lib, packages, I don't believe really contains anything that you need to know about. Okay, the last thing I'll mention is if we go to the root directory, the user lib folder has one sort of important, so if we go into user and then lib, it's got some shared libraries again, similar to the opt lib, with one important difference. The CCaux libraries are located in this folder. So in some versions of the OS, there's the CCaux libraries also in opt.lib, but those are not used, or they shouldn't be used. The ones that should be updated are here in user lib. So for instance, we'll see libccaux 283. So these are all symbolic links pointing to 283 here. So we'll see all these point to CCaux 283. And if we do a CC settings console version, we'll see our CCaux version is 283. So to essentially update the CCaux libraries, if you ever need to pull them off of the display to put them back on the virtual machine, or update them from the virtual machine onto the display, the CCaux shared libraries, which control the hardware of the device, are located in user lib. Okay, I think that sort of should explain some of the display content. You know, as you create, so if I had Code Assist installed on this display, there would be a Code Assist control folder located in the opt folder, which would contain all of the libraries and files to support Code Assist on the display. And when you created your application and set it to be bootable, that would also be located in the Code Assist control folder in this opt directory here. And then as you may see here, as you create Qt applications and build them to the display, these are what these folders are for me. So for instance, I've created a Qt application called persistent variables demo. And we can go in there and look, and here is my executable for that. So this is my executable Qt application. So as you create Qt applications, you can come to the opt directory and execute them directly from their folder here in opt directory. You can go into your Code Assist application and execute that directly from here. And it also contains the libraries and startup scripts that we already discussed. Okay, I think that does it for this video. Check out future videos where we'll be going over how to do specific things like adding a splash screen or you know, copying your Code Assist folders back to a host machine. Thank you.